Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problems list. Today I will be doing problem number 73, which is called set matrix zeros, and I think this is a fairly tricky problem in one of the approaches that we're going to discuss in this problem. Definitely a problem that you can find in an interview, so let's get to read the problem statement and let's get to programming. So the problem statement says, given an m by n integer matrix, if an element is 0, set its entire row and column to zeros. You must do it in place. So in place means that we're going to be modifying the original input, which is matrix, which is a 2D list of integers, and we're not going to return anything. So let's see example 1. So example 1, we only have one entry, which is a 0 right here. And then we have the output corresponding to this, so that makes sense because the row with index 1 is the only row that has zeros, and the column with index 1 is the only column that has zeros. In example 2, the only row that has zeros is the row with index 0, and the columns that have 0 are this one and this one, which are the columns with index 0 and the column with index 3. So this, and this are set to 0. Okay. So now I'm going to discuss how to do the problems. So if you want to try these by yourself, as usual, the link of the problem is in the description. And now would be the right moment to pause the video. So let's get to it. So there's going to be two approaches that we're going to do. The first one is going to be less efficient, space complexity wise. And I'm going to do that first because I think it's a little bit more intuitive. And after that, what we can do is just modify that approach so that it's more space efficient. So let's get to the first one. So the main idea here, like it says, it's if an element is 0, set its entire row and columns to zeros. So how are we going to determine whether a row or a column must be set to zeros? So the idea here is that we can create two storage systems. We can use a set. A set will probably be pretty good for this problem. We can create two sets that will represent the indices of the rows that must equal 0 and the indices of the columns that must equal 0. So whenever we loop through the entire matrix, right, in this case, for example, we encounter a 0, and this zero right here is located at row 1 in column 1. So in the set of rows, right, we will enter a 1, and in the set of columns, we will enter a 1 as well. And then after that, simply what we do is we explore what rows and what sets are stored in those, and then we set all those rows and sets equal to 0. For example 2, right, only the first row, so the row with index 0, has zeros. So then the set of rows will only have a 0 in it, but the column set will have a 0 and a 3 because the column with index 0 and the column with index 3 has zeros. So let's get to code it. So we have rows to 0 is this, and then columns to 0 is this. So we can simply loop through the matrix. And then if the current element that we are looking at is a 0, that means that that row and that column must be set to 0. So I represents the rows and J represents the columns in this case. Okay. So we have taken care of storing, of traversing the entire matrix and knowing which rows and which columns must be set to 0. Now, let's loop through the rows. So for each I in rows to 0, I'm going to add a little space here just for readability. So here we know that that row must be set to 0. So every column in that row must equal 0. So for j in range length of matrix sub 0, right? Because let's look at example 2, since this dimension and this dimension are different. Length of matrix 0 here is 4, which is the number of columns, and I is the row that you're at. So we're going to loop through a range that's length of matrix sub 0 long. And then we do the same thing with columns. In this case, the number of entries in a column is equal to the number of rows. So for any problem, that will be length of matrix. Here we can see that the length of matrix is 3 because there are 3 rows, which makes sense because each column has 3 entries. And that approach should work. Okay, there you go. You know, a little bit inconsistent with times, but the point is that this solution is one of the most efficient time-wise, but not really space complexity-wise. I've tested it before as well, so don't worry too much about these runtimes. As I said before, they're pretty inconsistent. As you saw, now it's like in the top 88.42 percentile. But yeah, so what is the runtime complexity of this problem? The runtime complexity of this problem is big O of m times n, where m is the number of rows and n is the number of columns, because we traverse every single element of the matrix at least once. And then what is the spacetime complexity? So let's think about it. So what would the worst case scenario be storage-wise here? The worst case scenario will be that every single row and every single column, right, has at least 1 0, meaning that rows to 0 will have m elements and calls to 0 will have n elements. Remember that sets have unique elements, so at most they'll have m and n respectively. So in the worst case scenario, we will have m plus n elements stored in memory. Therefore, the spacetime complexity of this solution is big O of m plus n. Now, as I said before in the beginning of the video, there is a more space-efficient approach. And if you came up with this solution by yourself and now want to try to optimize it space complexity-wise, now would be the time to stop the video and think about it and try it yourself. Okay, so let's discuss how to do that. So in the original approach that we used, right, we're using sets to determine what row and what column we must set to 0, but that uses extra space. So the question to ask is, okay, is there a way that we can modify the original input so that we can see the input and be like, okay, well, this row must be set to 0, or this column must be set to 0? And the answer to that question is yes, there is. So how do we do that? So the main idea here is that whenever we encounter a column, right, or sorry, an entry that is equal to 0, we can set the first column and the first row for that. So if this is a column I, a row I and column J, then we can set the first entry at that column and at that row equal to 0. Those will be the markers, right? Just like the sets here were our markers. And after that, when we modify, we simply look at whether, we look element by element, and then we check whether the first element in that column is equal to 0, and whether that element, whether that entry in the row is equal to 0 or not. Whether the first entry in that row is equal to 0 or not. So let's look at example 2, for example, right? Actually, let's do example 1 and then example 2, because there's an exception to this rule that I'll explain in a bit. So here, we traverse through this row. There's no zeros here, and then we encounter a 0. So what do? So what we do is we set the first element in that column to 0 and the first row equal to 0. And then we just keep traversing. So that would be the equivalent of doing the set operations that we did here. And after that, it's our turn to go through the rows and the sets. I'm going to explain in a bit why we do this, but I'm just going to go with it right now. We're going to start at the second row and the second column, and from there, we're going to go beyond. And after that, we do the first row and the first column, and example 2 will illustrate why we do that. So here, we start at 0, 0, and in this, like at any given location in the matrix that we explore, we check whether the first row and the first column is equal to 0. Since that's the case, we set it equal to 0. It was already 0, so no problem with it. Here, we check whether the first column, which is the 1 here, or the first row is equal to 0. The first element in the row is equal to 0. And remember that we modified it, so for this case, it is a 0. And then we go again in the second column because we will deal with these later. We go with this, and then we check that the first element in that column is a 0 because we modified it before. So we modify this to 0, and then none of these, like neither this one or this one, is a 0. So why do we do the first row and the first column last? So example 2 can illustrate why. So let's suppose that we have processed like everything that we need to process, right? In this case, after we've done all the equivalent of the set operations, these are the only zeros that we have set. Let's start with the approach that I've discussed previously. So let's start with this, right? Here we check whether the first element in the column or the first element in the row is 0. They're not, so we leave them the way they are. Similarly with this, and now with the 2. Here we set it equal to 0 because while this one is not a 0, this one is a 0. So we set this equal to 0. This one, we compare with this and with this, it's not a 0. This is not a 0. And then for this one is a 0, so we set it equal to 0. Now, what would happen if we did the first row and the first column before? If we do the first row, right, here we check the first row, so we set this equal to 0, and then we set this equal to 0. Right? And then we set this equal to 0, and if you notice, no matter what, all this will always be 0 because we've previously set we set this equal to 0 and we set this equal to 0 already. So that already does not match our output. But this does not take care of everything as well. So let me explain why. So let's look at the cases for the second row and the second column. I think this might be a little bit easier to illustrate what we're going to do now. So I'm going to delete this code, okay? Oh. Okay, so cases for the second column and the second row. So none must be zeros, okay? Then another case is that second column must be zeros and the other one isn't. The other case is the second row must be zeros, but the other one isn't. And then both are zeros. So how do we know? I don't know if it's I don't know if the E follows the O, whatever. So what happens when none are zeros? That means that neither the first entry in the second column is a 0 or the first entry in the second row is a 0. So the first entry in the second column, let's see, the first entry in the second row, that will be this is not equal to 0. Or the first entry in the second column. And, sorry, there you go. So that's what happens there. When this happens, we have found that the second column must be 0. So if the second column must be zeros, that means that the first entry in the second column is equal to 0. For this one, this will be the case, right? And for this one, this is a case. And now you'll see why the first column in the first row is a special case. In this case, right, we have two different entries in the matrix where we can just check. So we check this one or this one. But in the case of the first row and the first column, they both share the same one, right? Like the first entry in the first row is the same entry as the first entry in the first column, right? It's this one right here. Therefore, we only have one entry in the matrix that can either be a 0 or a non-zero to handle four different cases. But that's not possible, right? Because we only have two possibilities. Either one is a 0 or one is not. So we must create another variable. In this case, we're going to choose the column that represents whether the first column must be set to zeros or not. So we can create a Boolean flag for is the column a 0. That way we will have two different things to look to, just like we did in the second column and the second row. Because if we only focused on one, right, the entry can either be a 0 or a non-zero element. But because we only have one possible element, there's only two possible cases that we can cover at most, but we need four. And that's why we create the Boolean flag here. So let's get started with it. So is column 0, we'll set it equal to false in the beginning. And then we can just loop through the matrix. So for I in range, let's say length of matrix. Oops, sorry. For j in range. This is another special thing, is because we are gonna keep track of the columns right here, right? With a flag, we don't need to loop through these with a for loop, with the inner for loop. So we're gonna start at index 1 for the columns. And once again, remember that matrix of 0 represents the length of the rows, and length of matrix represents the length of the columns. So when do we want to set the columns equal to 0? Well, we want to set them equal to 0, right, whenever we encounter the first element of a row that's equal to 0. So that would be if matrix sub I sub 0 is equal to 0, then is column 0 equal to true. And then here, we simply do if matrix sub I sub j is equal to 0, then what we do is we set the first element in that column and the first element in that row equal to 0. So matrix sub I sub 0, so the first element in that row equal to 0, and the first element in that column equal to 0. And that handles the equivalent of the set operations that we were doing before. That handles the indicators. Now we're going to start modifying the second row and the second column and beyond. So for I in range 1 length of matrix, and for j in range 1 length, this should be, yes, it should be for I in range, yes, okay. Sorry, I was getting a little bit mixed with the ranges and the lengths. There you go. Oh, I can't type today. Great. Okay. So, if for the current element, right? So if matrix, So here we're looping through like any element. So if the first element in that column or the first element in that row is equal to a 0, then we set that element equal to a 0. So if matrix sub I sub 0 is equal to 0, or matrix sub 0 sub j is equal to 0, then we set that element equal to a 0. Now we can handle the first row. Like we mentioned before, right? The Boolean flag takes care of the zeros. Just like matrix, like in the second column, right? In this example right here, The second column is taken care of by matrix sub 0 sub 1. The column will be taken care of by the Boolean flag, and the row will be taken care of by entry matrix sub 0 sub 0. You could do it backwards as well as you want. Just make sure that you loop through the ranges properly. Okay, so here let's do the rows first. So if matrix sub 0 is equal to 0, so this is if the rows, if first row must be set to 0, then what we do is we loop through all the entries in that. So for j in range length of matrix sub 0, matrix sub 0 sub j equal to 0. And then if the first column must be set to 0, and that is determined by the Boolean flag right here. So if is call 0 is equal to true. And I know that the equals true is not necessary, but I think it might help with readability for some viewers, so I'll just leave it there. For I in range length of matrix, because remember, we're going through columns, so we're going through the length of the matrix. Matrix sub I sub 0 is equal to 0. And this approach should work as well. It doesn't. Okay. So let's see the small mistake that we have here. So for j in range, okay. For I in range, length of matrix, I sub 0, 0 sub j. Okay. Should be fine. Okay. All right, I'm back. Yeah, I just made a small mistake here with this right here. I set it equal to like this before. So this is the only modification that we need to do. Just a small error. And there you go. Now this should work. Just if you get enough tries, it'll eventually, you'll see that the memory usage is a little bit better. So what is the runtime complexity of this problem? So the runtime complexity of this problem is, once again, O of m times n, because we run through every single entry of the matrix at least once. And now what is the space-time complexity of this problem? Well, the only thing that we're storing is just one Boolean variable, and that is O of 1 space. Therefore, the space complexity of this solution is big O of 1. So yeah, that will be the end of the video. Here you have some code. If you wanna take a look at it, just pause the video and scroll through. But yes, this is the end of the video. I hope you enjoyed it and you found it helpful. This problem can be a bit tricky, especially the second approach. So take your time to digest it. And yeah, thank you very much for watching, and bye-bye.